Hey, this is Chris with Inertia Lab. Today I'm going to be showing the basic process of rebuilding an internal floating piston shock. In this case, it's going to be an Icon 2.5. So typically, like with the front here, the first thing you got to do is remove the preloaded spring. So sometimes these are preloaded with nearly a ton of preload. So this not so much, but still use the right machine to get it off and you don't have any mishaps. All right, so lay out some tools, get the seal kit ready, and the first thing you do once you have the spring off is essentially just look it over. You know, are there any dings and nicks in the shaft that would prevent the rebuild from causing another leak? Just basic stuff like that. You know, is anything bent? You know, in this case, nothing's bent. This set's actually in really good shape. So next step is essentially to get the nitrogen out of it. So you can poke it with a needle in this case, or you can just kind of brute force it and take the plug out and let it drain off that way. Which sometimes there's oil, there's a separator piston in here between the oil and the gas, and sometimes gas contaminates the oil and the oil gets into the gas chamber. So you got to be careful about that a little bit so you don't spray yourself with oil, but for the most part, it's pretty harmless. So now that the gas is out, we're going to start taking off the top cap and remove all the guts of the shock and go from there. So this little clip, this little circlip in here that holds the shaft guide in. So catch down there. All right, next we remove the floating piston, the separator piston in here, and I do that just with a little bit of compressed air or into a box. Easy peasy. After you've pulled the top guide out of the body, essentially that's where the piston and valve stacks are all positioned. This is just a spacer. This is a shaft guide. It's got a bearing in there with a Teflon lining, and then the seals are in there. This is a spacer, you know, just to give the right droop travel, and also it kind of helps space the load between these two. This supports the side load of the spring as well. So, and next is to get this top nut off, get the valve and all the valve stack off, lay it out, clean everything up, get this off, place all the seals, and be nearly ready to put it back together. So on this valve stack, it's got this stack that came off first, and then underneath it's got this spacer shim. So this is a digressive piston. So this has a certain amount of distance between the face of this deck, where the outside of this shim sits, and this pad right here. So it allows, when you clamp the nut down, it compresses the shims and preloads them against here, so there's a certain pressure that has to be overcome to release the valve stack in the first place. So here on the compression side, there's also this little spacer shim that sets the amount of preload, but there's also, they call this a number of things, like a double Christmas tree or a flutter stack or whatever. There's this one shim that sits against the face of the piston, and it's the preloaded shim. And then there's this other spacer here that gives a different height before this whole stack is engaged. So essentially at lower speeds, you have a certain lower damping rate and compression until this shim flexes and touches this stack. And then you get a higher rate. So, you know, large bumps, maybe you catch a little bit of air. It'll help control that when you're coming back down. I think a lot of people think that these shims flex 2-3 millimeters and stuff, but they flex fractions of a millimeter. They're very, very low deflection, so it doesn't take much space in between. Then at the bottom, there's these cone washers. It's just for topping out. It gives a little bit of a cushion when you top out as opposed to having a piece of rubber in there. And now the seal head comes off easily. It installs a little bit easier from this direction as well. We'll take it over to the bench and rebuild it. All right, so now we got most of the guts out on the bench. We got the Icon rebuild kit that we're gonna replace everything with. So as far as a full rebuild goes, you know, unless something's broken, like sometimes these cone washers, those have broken and it just kind of like ruins everything else. We replace essentially the oil. We clean everything out. So if there's any dust or debris or corrosion or anything like that, we get rid of all that so that the whole valve stack and everything can work better. Yeah, just go over everything with a fine tooth comb, make sure it works as it should. So typically one of the obvious places to start is either with like, you know, the floating piston with the seals. Just use a seal tool. You don't always have to use a seal tool, but lay out all the O-rings and stuff, get those ready to be replaced. There's that guy. And you got to be a little careful going in there after the seals that you don't scratch the outer groove, because these seals seal against the outer groove as well. So it's another thing to just keep in mind. And then so there's this orange bearing in here, which is a DU bushing. So sometimes it can become either too embedded with garbage. It'll tolerate a certain amount of debris coming through it. That's one of the benefits of them. They can tolerate some amount of contamination and still function and provide low friction and not, you know, wear out the surfaces. But there is a point where they're obviously ruined. You just look and make sure that it's not absolutely horrendous looking and that it's not worn through. You can see the bronze backing on underneath the Teflon. The Teflon's a very thin layer, but it wears very slowly. So as long as everything looks good and it's not worn through, they're good for another round. Sometimes these things will last a couple of rebuilds, so it's worth checking because it can cause leaks if the shaft can rock too much. It can cause leaks. It does get side loaded even in a shock by the spring. The spring doesn't have a perfectly straight up and down load. It's kind of diagonal, when, especially in a flush ground spring. So these do see a little bit of load, but not a huge amount. So the next thing you look at is the wear band on the piston. Just to make sure it's got a good even coating still of the Teflon across it. And if this has been run dry or there's a massive leak and a bunch of dust and dirt gets in, you'll find that these are all wore out. There's, you know, they don't survive if you're just running them dry for super long, although they will survive a lot. And on the piston, you always know which side is intended to be rebound, even if they're dimensionally similar and it wouldn't make a difference. Usually the larger amount of access ports or port area, like this has 8 holes in it, so versus 4. So this is going to be the compression side of the piston as it's referred to. And this will be the rebound, because generally compression is dictated by what the road does to the suspension, and the rebound is just as fast as the spring can push it down. So it's much more limited by the spring than it is by what you're going to run over. So next is a bunch of cleaning. So essentially we're going to clean all the parts, like stuff like top guides and floating pistons, clean it up as best we can with you know, whatever the most efficient way we can get the large majority of stuff off. And then we either clean it in the parts cleaner with a brush, or we put it in the ultrasonic if it's really bad, and just let that eat at it for 10 minutes or so, and once that's out, it'll get into all these little grooves inside here where the seal sits. There's not a whole lot usually to clean in there, and blasting it out with brake clean is often enough. But just to be safe, sometimes I just throw stuff in the ultrasonic. It doesn't hurt anything, it only helps. So that's what we're gonna do next. We're just gonna clean a bunch of stuff. So as I'm cleaning stuff, it's good to make sure like every little groove is clean, just in case a speck of dirt or something gets under there. It can really affect the valving more than you might expect. Having worked on a bunch of race car shocks where dynoing everything is much more common and done at very low speeds, where tiny little amounts of debris can affect valving at low speeds a whole lot. You get to know just how much an eyelash or just a speck you can hardly see can make a difference in how the shock performs. So something we go through and clean all the shims. And also the shims are inspected for damage, cracks, corrosion, fretting, all kinds of stuff. And if they look too bad, we've built thousands of shocks. So we know when they're too bad and need to be replaced. The usual cause of death is slamming over a bump. So they've deflected and you can see that they're permanently deformed, or just running them dry and they get corroded, stuff like that. I get to check each one, and you want to put them back how they were originally flexing. You don't want to flip them over and flex them the other direction. It'll just fatigue them faster, if anything. So on the off-road stuff, we try to take apart as much stuff as possible. That kind of carries over from the race car stuff. I know not everybody does full rebuilds each time that they service something, and to that point, sometimes it's, sometimes you can get away with that. It's not always needed. But if it's the first time we've seen something and we know it's got 60, 70,000 miles on it, it's just a really good idea to go ahead and go through everything and do a full rebuild. Not only is it better for you so that you have less potential problems, it's better for us because you have less potential problems. It just, everybody's happier. This isn't an unusual rebuild of any kind. So even though it's fairly low mile shock, you can see from the oil, still very dark. There's no debris in it, there's nothing like horrible. You can see some stuff because things still do, but even though there's seals there and they may not be leaking, stuff still can get by. It's usually very small though, but it's like anything. You work the fluid. The fluid's where the energy dissipates, so it's internal friction. And when, like anything, even if you wear two steel pieces to, you have friction between two steel pieces, it creates wear. The oil wears out, all kinds of molecular chains get broken, and eventually it turns black, and it even if your shock's not leaking, it may be underperforming. When that exactly happens depends on how you use it. So just because it's not leaking doesn't mean you've got a great shock. That's something we've learned using the dyno over and over. Even brand new, sometimes things are wrong. So another area of wear is between the piston and the band. So you can see there's witness marks of the wear on the inside of the band as well. So it's not exactly the exact same diameter as the groove. So there's maybe a 0.5 millimeter of travel up and down. So as the shock's going up and down, this is sliding up and down on the piston. Usually that's not very much of a problem. You'll know when it is because it'll look really rough, and you just want to inspect all the lips and things, just general stuff. It's usually not too big a deal, but an eye for detail will prevent a setup from behaving differently than it would have when it left the factory. All right, so when we're resurfacing a shaft, which we try to do each time, because there's always something some way somebody's grabbed, or just lines. Even after 20,000 miles, there's marks and lines. It doesn't mean they're bad. It just means they can be better. So we have 2 to 3 step process depending on how bad they are. So this doesn't need the rough run in. It just needs a ultra fine and a cleanup pad. So that's what we're going to do on these. So when I'm polishing or resurfacing a shaft, I like to run it both directions so that there's a scratch with a ridge. I hit both peaks on either side of the scratch. I think it just winds up working out better. Essentially, I just like to get it from both directions. That's right. So another thing to look at with these is just inside the bore here where the seal head sits. There can be a lot of marks. If these have been rebuilt, sometimes there's scarring from previous pick marks. If somebody hadn't been careful, there's corrosion and old O-ring matter. So if we see that, I like to hone it out, make it look like the rest of the bore so that everything goes back together and doesn't leak. So after you get the seal head on and rebuilt, it's time to put the whole shaft back together with all the shims and the piston. After that, we're going to set the floating piston and fill it with oil. So everything's back together, clean and ready to reassemble and fill with fluid. So the way on an IFP, there's several ways to do it, but it kind of depends on what your limiting factors are. So a lot of times with off-road stuff and even race cars with short rear shocks and whatnot, the limiting factor is how much volume or distance is left for the floating piston to travel. So it might fit within a very tight range, and it has to be assembled very accurately sometimes. So this one has a fairly small margin for where to set the floating piston, so that as this goes in, it doesn't contact it prematurely and then cavitate, or even worse, it hydrolocked because the piston was set too low and it just stops at the bottom, and then that causes all kinds of other problems. So really at the bottom of the stroke, at full compression, where this thing is bottomed out, worst case scenario, you want the floating piston to have some room left from the bottom, but also not be contacting this. So essentially this is how it's going to sit in there, and you want to have some gap. I usually give 3 to 5 millimeters. It's enough for when you're filling it back up with gas. If there happens to be an air bubble, there really shouldn't be, but seals squish out into their grooves and things like that, so it'll move up a little bit. But that's the idea, is to set the floating piston at an accurate height to where there's as much nitrogen volume as you can get, but will never contact the piston or the bottom of the bore. So now we're just going to add the icon fluid back to the shock, load the shaft assembly, and then we'll go fill it with gas. Top off. So now that we've got everything assembled and the snap ring in, you always want to check full stroke to make sure you have it without contacting the piston. But since I assembled it with the floating piston at the fully compressed position and then loaded the shaft to the fully compressed position, it kind of checks itself once you assemble it. So now all we have to do is fill it with nitrogen pressure and clean it up, and it's ready to go once we test it. So now we got this all cleaned up and looking good, which is the goal with everything that we rebuild. So hopefully this gave you a more detailed look at our process, and hopefully we'll see you in the next video.